Welcome to the Bodhi Academy. My name is Amisha Kulaso, and today we are going to continue with the chapter Rational Numbers of Class 7. So previously in this chapter we saw what are rational numbers. So rational numbers are basically denoted in the form of p by q, where q is not equal to 0. Then we saw the numerator and denominator part of the rational numbers, where we say that p denotes the numerator and q denotes the denominator. Further, we also learned something about equivalent rational numbers. Now when I say equivalent rational numbers, we saw that their final values remain the same, but they can be expressed in different forms. Further, we also saw something as positive rational numbers and something as negative rational numbers. So in today's class, we'll see rational numbers on a number line, comparison of rational numbers between two rational numbers, operations on rational numbers. So now let's begin with rational numbers on a number line. So now we already know how we denote a number line. So say we have a number line with 0, 1, 2 and 3, and on the other side we have -1, -2, say -3. So this is the negative side and this is the positive side of the number line. So now say I want to show -1 by 2 on number line. Okay, so now how will I show it? So now we know that -1 by 2 is basically -0.5, and 0.5 comes between 0 to 1. So here now if I have to denote both -half and +half, so we know that this distance, as in -half will be on the left side of 0 and +half will be on the negative side of 0. So in this case, so say this is my number line and I'm going from 0 to, say this is my 1 and this is my -1. So in this case my 0.5 or my +half will be somewhere here, and in this case it will be somewhere here in between 0 and -1 and 0 and +1. So here what we'll know is that the distance between 0 to -half and 0 to +half will be the same. Okay, they will be at a equal distance. So this is how we show rational numbers on a number line. Now moving ahead, let's see rational numbers in standard form. So now when we say rational numbers in standard form, a rational number is said to be in standard form if its denominator is a positive integer and the numerator and denominator have no common factor other than 1. So to understand this, let's take an example of this, -45 by 30. So the first thing they said over here is that for the rational number to be in standard form, the denominator should be a positive integer, and here we have our denominator that is a positive integer. So then so now let's try and solve this. So now the next part is that the numerator and denominator should not have any common factor other than 1. So in this case 45 is there. So 45 does have many other factors, like we'll have 3, we'll have 5 here, then we can have more such, can have 9 also, which is also a factor of 45. So here what this factors need not be more than 1. So now if we cancel out this 45 and 30, so say we cancel out in table of 5. So 5, say 5 6 are 30 and 5 9s are 45. So in this case we are left with 9 and 6. So 9 and 6 have more common factors than 1. So still we can go further. Say we can go by 3 table. 3 2s are 6 and 3 3s are 9. So now here we have finally minus 3 by 2. Now minus 3 has only one common factor, that is 1. It comes only in its own table, and so does 2. So now we can say that we have reduced minus 45 upon 30 to its standard form, that is minus 3 by 2. Okay, so let's take another example to understand this. Okay, so say I have say we have minus 36 by 24. So let's try to reduce this. So first we can start with the table of 2. So we'll get 2 1s are 2, 2 2s are 4, here 2 1s are 2 again, and 2 8s are 16. So we get first standard form 18 upon 12. So this can be further reduced. So again let's cancel out in the same table of 2. 2 6 are 12, 2 9s are 18. This still can be reduced to 9 by 6 we have. So 3 2s are and 3 3s are. So the final answer that we'll get is minus 3 by 2. So again we have reduced it to the standard form. Okay, so this is how we have to reduce, or we have to bring the rational numbers in their standard form. That is, the denominator should be positive integer and the numerator and the denominator should not have any other common factor apart from 1. So now moving ahead, let's try to understand how comparison of rational numbers takes place. So now when we see the number line, so 0, 1, 2 and 3, minus 1, minus 2 and minus 3. So now to understand the comparison, let's say we have 3 and we have 2 now here. So our 3 is on the left hand side of 0. So on the side of the positive side of the integer line, we have to remember that the numbers on the left hand side are always greater than the numbers on the right hand side. So see, now here we have 2 and 3. So if we look at 2 and 3, so 3 is greater than 2. So to remember, we have to always remember that for positive integers, the numbers on the right hand side are greater than the numbers on the left hand side. Now moving to the negative side. So when we talk about the negative side, we have to remember that again the same rule applies. The numbers, okay, the numbers which are on the right side are always greater than the left side. So this is something we need to remember. So same thing will be applicable over here. So say we have minus 3 and we have minus 2. So we can say that minus 2 is greater than minus 3. Now these were simple numbers. Now how do we compare rational numbers, which number is greater and which number is smaller? So now let's take an example. say we have minus 1 by 2 and we have minus 1 by 5. This we have to firstly we'll directly try to reduce this, or we'll try to compare these two numbers. Now to compare any two numbers, the first step is to make their denominators same. So denominators should be same. Okay, so now we have minus 1 by 2 here and we have minus 1 by 5 here. So if we take the LCM, we'll get as 10. So say here we'll write minus into 5. This will be also into 5. This will be into 2 and into 2. So this will be equal to 5 upon 5 2s are 10, and here we'll get minus 5 and minus 2 upon 10. So we have got, now our denominators are same, and now let's try and compare it. So we have minus 1 by 2 what we initially had, so minus 1 by 5, and now we have currently with the same denominators minus 5 by 10 and we have minus 2 by 10. So now let's see. So what we said here was the numbers on the right side are always greater than the numbers on the left side. So now since our denominators are same here, so if we draw a number line, so we'll start with say 0 by 10, 1 by 10, 2 by 10, 3 by 10, 4 by 10 and say 5 by 10. All are negative. Okay, so all are negative. So now we said numbers on the right side are always greater. So first on the right side we have minus 2 by 10. So here we can say that minus 2 by 10 is greater than minus 5 by 10. And here also we can say minus 1 by 5 is greater than minus 1 by 2. Now say we have maybe a positive and a negative number. Say we have minus 1 by 5 and say I give you plus 7 by 5. So here we need to remember that a negative rational number is always less than a positive rational number. What I said is a negative rational number, so write it down here, a negative rational number is always less than a positive rational number. Okay, so in this case what will be the answer here is, so we have minus 1 by 5 and we have plus 7 by 5. So plus 7 by 5 is obviously going to be greater. The simple reason we could say that same as what I told you all here, that 7 by 5 is going to be on the right side, whereas minus 1 by 5 will be on the left side. So therefore automatically 7 by 5 becomes a greater positive rational number. So now let's move ahead and understand how do we find rational numbers which are in between of any two given rational numbers. So okay, so the first example that we'll have is say minus 1 and 0. Say I have to find 5 such numbers between minus 1 and 0. So we begin by making their denominators the same. So say I have minus 1 here, so I'll have say maybe 6, okay, into I do say minus 1 upon 6 into 1. Okay, so this will give me what? Minus 6 upon 6. This will in return give me the same answer as here. And then say I have 0, so I can write maybe 0 upon 1, so that will give me 0 into 6 upon 1 into 6, so I'll get 0 upon 6. This is if I do further, we know 0 by 6 will be 0. So now the in between rational numbers will be very easy here. So we have numbers from, so we have 0 to 6 to minus 6 upon 6. So now what we are going to do is simply write all the numbers that come in between these two numbers. So we have to begin with 0 by 6, then we have 1 by 6, then we'll have 2 by 6, 3 by 6, 4 by 6, 4 by 6 and 5 by 6, and last we have 6 by 6. Okay, so here all negative. So we have got all our 5 numbers that come between 0 and minus 1. So this is actually equal to 0 and this is actually equal to minus 1. Okay, so now moving ahead, so list 5 numbers between minus 4.5 and minus 4.5 and minus 2.3. So now let's begin by making the denominator same. So we have minus 4 by 5 and we have minus 2 by 3. So in this case, let's take maybe 9. So here we'll have, this will be into 15. So our denominators are going to be 45 into 15. So here we'll get what? 36 upon 45, and here we'll get 30 upon 45, minus 30 minus 36. Now you have to write all the numbers that come between these two numbers. So we'll begin with minus 30 upon 45, then we'll have minus 31 upon 45, minus 32 upon 45, minus 33 upon 45, minus 34 upon 45 and minus 35 upon 45. So we have got, last we have minus 36 upon 45. So this equals to minus 4 by 5 and this equals to minus 2 by 3, and these are the numbers that come between minus 2.3, minus 2 by 3 and minus 4.5. Now we'll try to solve these examples quickly. So now fill in the boxes with the correct symbols out of greater, lesser or equal to signs. So now to begin with the first one, again we try and make the denominator the same. So we have minus 5 upon 7 and we have 2 upon 3. So if we take here 3 and if we take here 7, we'll get 15. Okay, so the answer here will be 5 3s are 15, minus 15 upon 21 and minus, okay, positive 14 upon 21. So now basically we have converted and made the denominators the same. So we have minus 15 upon 21 and we have 14 upon 21. So now speaking between these two numbers. Okay, so now the denominator is same, but remember what I said on top was that we made a note here that said negative rational numbers are always smaller than positive rational numbers. So we have a negative rational number here and we have a positive rational number here. So obviously our positive rational number is going to be greater in this case. So moving ahead to the next one, say we have 5 and here we have minus 5 upon 7. We can take the denominator as 35. So into 5 into 7 into 5. So we'll get here minus 7 4s are 28 upon, we'll get 7 5s are 35. Here we'll get minus 25 upon 35. So here we remember that the numbers which come on the right side of the number line, or the numbers which appear to be lesser, okay, will be the greater ones. So we have 35. Okay, or else another thing is when we have two negative numbers and we have to give them a symbol of greater and lesser, the simple thing we could do is just in the first step ignore the negative sign and look for which is the greater one. So in this case 28, so if we ignore this sign, okay, I'll just do it here. So we have 28 upon 35 we have, and say we have 25 upon 35. Now this here we have ignored the negative signs. So in this case we know that 28 upon 35 is greater than 25 upon 35. So when we are having negative signs, this sign is just going to be reversed. So what we can do is, just for a mental math, we can just ignore these negative signs first, give the sign, and then when we are writing it for the negative answers, we have to just reverse the sign. So in this case the sign was towards 28, it will be reversed to minus 25 being the greater number. And now lastly we have 0 and minus 7.6. So say now if we solve minus 7.6, we get an answer of maybe 1.166. okay, so in this case we'll have minus 1.166. okay, there's a negative sign, there's a negative sign here. Okay, so then, and we have 0 on the other side. So what we have said is a negative number is always less than a positive number. So in this case also 0 will be greater than minus 1.116. Now moving ahead finally to the last topic of this chapter, we have operations on rational numbers. So these are the basic operations that we have. Say we have addition, we have subtraction, multiplication, and we have division. So these basic operations we are going to learn how to do them on rational numbers. So let's start with simple addition. Okay, so let's take an example of minus 3 by 7 plus 2 by 3. So first step remains the same, we take out the LCM and we make the denominator same. So LCM of this will be, so we have 7 into 3 will get 21. So minus 3 upon 7 into 3 plus 2 upon 3 into 7 into 7. So here we'll get minus 9 upon 21 plus 14 upon 21. So this, if we solve, we'll have minus 9 plus 14 upon 21. So the final answer that we'll get is 5 upon 21. So this is basic addition. Here we did, what we have done is, because plus into minus is minus, so we subtract this answer. 9 plus 14 we subtract and we get 5 upon 21. Moving ahead to subtraction. This is also done in a similar way. All that we do is we make the denominator same if they are not same. So minus 5 upon 6 plus minus 3 upon 11. So now here we know that, we know the sign rule. So let's first, let's make the denominator same first, then we'll look at the signs. So here our LCM will be 6 into 11, that will be 66. So upon we take 6 into 11 and into 11 plus we have minus 3 upon we have say Here we have 11 into 6 will give us 66. So minus 55 upon 66 plus 6 3s are 18. So minus 18 upon 66. So now here what we can do is we'll have minus 55. So now plus into minus is minus. So here we'll get minus. This will become 18 and denominator is 66. Now again minus into minus is plus. So here we are going to add. So 55 plus 18 is going to be minus 73. Minus because 55 being the greater number has a negative sign. So that negative sign comes to 73 and we'll have 66 in the denominator. Now going ahead to multiplication. So multiplication. Now say I have minus 4 by 7 into 3. Okay. Now when there are numbers like this, what we do is simply, see, now there are two methods here. One is a number line method and one is direct multiplication. So let's look at method number 1, that is the number line method. So in this what we do is, this is my number line say, and so this is my 0 by 7. Okay, so I have minus 1 by 7 here, minus 2 by 7, minus 3 by 7, minus 4 by 7, minus 5 by 7, minus 8 by 7, minus 9 by 7, minus 10 by 7, minus 11 by 7, minus 12 by 7, and say minus 13 by 7. Okay, enough. This much is enough for us. Okay, so say this is our number line. Okay, so now how do we start? So this number here, it tells us that we have to take 3 jumps. Okay, and this number here means we have to include 4 such jumps. We have to jump over 4 different numbers. Say I start from here. Okay, I start from here. So if I'm standing here, okay, now I have to jump over 4 numbers. So I'll jump from 1, 2, 3 and 4. I'll reach minus 4 by 7. So my first jump will be over here at minus 4 by 7. So now this is my first jump, and how many jumps do we need to make? Are 3. So now again same way I'll make my second jump. So 1, 2, 3 and 4. So we'll reach 1, 2, 3 and 4. 10 by 7. Okay, and so we have, okay, 5 is a slight mistake here. Okay, so here it is minus 6 by 7, minus 7 by 7, minus 8 by 7, minus 9 by 7, minus 10 by 7, minus 11 by 7, and here I have minus 12 by 7. So now from here again we'll make another jump, 1, 2, 3, 4, and from here I'll reach to this. So now I have made my 3 jumps, and at the end of the third jump I am at this number, that is minus 12 by 7. So now when I multiply, okay, now let's look at the, so my final answer basically here is for minus 4 by 7 into 3 is minus 12 by 7 by first method. Now second method is direct multiplication. So in this what we do is we multiply the numerators, both the numerators. So we'll get minus 12 and the denominator remains the same. So basically this is 1. So 7 into 1 is 7. So both our answers are same. So in these two methods we will get the same answers, that is for multiplication. Now last say is the division. Now when we do division, there is something we need to remember here. So now let's speak about reciprocals. Okay. Now reciprocals are, say I have A upon B. So when I say I want a reciprocal of A upon B, my reciprocal will be B upon A. It is basically changing the numerator and the denominator, or reversing the numerator and the denominator. Now say another thing to remember here, okay, note. Say I have A upon B, okay. I have A upon B, and what I'm going to say is here the product. When I say product, it means we are going to do multiplication. The product of A upon B to the reciprocal, or to its reciprocal, that is B upon A, will always be equal to 1. Okay. So now let's look at what it means. Say I have minus 4 by 9. Okay. So now the product of this, the product of minus 4 by 9 is reciprocal. So reciprocal will be what? It will be 9 upon minus 4. So here we'll get 4 9s are minus 36, and again down minus 36. So this minus minus gets cancelled and I will be left with 1. This is what it means. The product of the reciprocal of any given rational number will always be 1. So now let's solve one example for division. Say I have 4 by 9 divided by minus 5 by 7. So now here we can do one simplification. Now I told you all about reciprocals. Now when I am taking a reciprocal here, say now I have 4 by 9 and here I took a reciprocal. So I'll have 7 by minus 5. So now when I take reciprocal, what will happen is this division sign that is there, it will change to multiplication. So when I take a reciprocal of any number, if there is division, it will become multiplication, or if there is multiplication, it will become division. So here in this case we'll get multiplication. So here if I do this, so 7 4s are 28 upon minus 45. Okay. So in today's this video we learned, let's summarize. So we learned rational numbers on a number line, how we are going to denote rational numbers on number line. Then we learned to reduce rational numbers to their standard form, that is the denominator is a positive integer and the numerator and the denominator should not have any other common factor than 1. Then we saw comparison of rational numbers, that is how do we denote if which number is greater or smaller than the other ones. So here we need to remember that the numbers which are on the right side of the number lines are always greater than the ones on the left hand sides. And also another note, when we have like numbers a positive and a negative rational number together, we have to remember that negative rational numbers are always smaller than positive rational numbers. Then we learn how to find rational numbers between two rational numbers. Say I have minus 1 and 0. What are the rational numbers that will be coming in between? We learn how to find them. Further, we learned the basic operations on rational numbers, that is addition, subtraction, division and multiplication. Multiplication we learned by two methods. One is the number line method and the other one is the plain multiplication. And for division we learned something about reciprocals, and we said that a product of any reciprocal numbers is always going to be 1. So that was it for this chapter of rational numbers of class 7th. So thank you so much for watching today's video. Please don't forget to like, share, subscribe to the Bodhi Academy.